The figure to the right shows the essential parts of a hydraulic brake system. The area of the piston in the master cylinder is 1.8 centimeters squared, and that of the piston in the brake cylinder is 6.4 centimeters squared. The coefficient of friction between the shoe and the wheel drum is 0.50. If the wheel has a radius of 34 centimeters, determine the frictional torque above the axle when the force of 44 Newton is exerted on the brake pedal. Alright, so what are we given here? We are given area 1, which is this area here, of the master cylinder. That's equal to 1.8 centimeters squared. And A2 is given. Area of the brake cylinder. That is 6.4 centimeters squared. We are also given the friction coefficient, sub K. That's 0.50. And in addition to that, we are given the radius of curvature from the axle to the drum, and that is 34 centimeters. This is equal to 0.34 meters. You also know that the force exerted on the pedal F1 is given. That's 44 newtons. And what we are required to find is the frictional torque. Alright, to do that we need to find the force exerted right here. Then there will be force exerted in the opposite direction, and that will be the normal. So this is F2. If we can find F2, we can find N, because the normal is always opposite and equal to the force exerted, perpendicular. So we know that the pressure in this system is a closed system, therefore pressure is constant. That pressure is equal to F over A1, and also equal to F2 over A2. Pascal's principle. Alright, so we can rearrange this equation for F2. F2 will be A2 divided by A1 multiplied by F1. A2 is 6.4 centimeters squared. By that by 1.8 centimeters squared times F1, which is given to be 44 newtons. Centimeter squared goes with centimeter squared. 6.4 divided by 1.8 times 44 is 156.4 newtons. Therefore, we know that F2 in absolute value is equal to the normal. Therefore, we can tell the friction force. That friction force, because this one is moving in this direction, the friction force is going to be opposing it. That friction force, F sub K, is equal to mu sub K times the normal. Plug in the numbers. Mu sub K is 0.5, and the normal is 156.4. Therefore, the friction force is going to be 78.2 newtons. So what's tau sub K going to be? Or tau of friction? Frictional torque is going to be frictional force multiplied by the radius of curvature from the axle to the wheel. Alright, and that is 78, and they are perpendicular to one another. 78.2 newtons multiplied by R, which is 0.34 meters. That's equal to 26.6 Newton meter.